It begins, as most scientific corrections do, not with a roar, but with a quiet doubt, an unease buried beneath decades of certainty, because for over a century, we believed we understood the most terrifying predator to ever exist, a creature so massive, so powerful, that even the word shark feels insufficient to describe it, the Megalodon, a name that conjures images of a nightmarish leviathan, a monstrous great white scaled up to impossible proportions, endlessly patrolling ancient oceans, with a hunger that shaped entire ecosystems. But what if that image, the one burned into documentaries, textbooks, and our collective imagination, is wrong, not slightly inaccurate, but fundamentally flawed, because the truth emerging from fossil records, biomechanical studies, and evolutionary analysis suggests something far more unsettling, that Megalodon wasn't just a bigger version of what we know today. It was something stranger, something alien in its design and behavior, something we are only now beginning to understand. And the story of how we got it wrong begins with teeth, thousands upon thousands of them, scattered across the globe, fossilized remnants of a predator that left behind almost nothing else, no complete skeletons, no preserved bodies, just serrated blades of enamel, some the size of a human hand, whispering clues across millions of years, and from those teeth alone, scientists tried to reconstruct a giant, building an image piece by piece, assumption by assumption, until a narrative formed, one that seemed logical at the time, that Megalodon must have resembled the modern great white shark, because their teeth looked similar, triangular, serrated, built for slicing through flesh. And so the idea took hold, reinforced by early paleontologists and amplified by media, that Megalodon was essentially a colossal great white, perhaps 3 times the size, reaching lengths of 15 to 18 meters, a living torpedo of muscle and teeth, dominating prehistoric seas with brute force. But science is not static, and as new methods emerged, that narrative began to crack, because teeth, as informative as they are, can only tell part of the story, and when researchers began to look beyond shape, examining microscopic structures, isotopic composition, and wear patterns, they realized something unsettling, that similarity does not equal ancestry, that 2 creatures can evolve similar tools for entirely different lifestyles, a concept known as convergent evolution, and suddenly, the assumption that Megalodon was just a giant great white became less certain, because genetically and evolutionarily, the lineage of Megalodon diverged from that of modern great whites far earlier than previously believed, placing it closer to an extinct family of sharks known as otodontids, creatures that occupied a very different ecological niche. And this revelation opened a door to a cascade of new questions, because if Megalodon wasn't built like a great white, then what was it actually like? How did it move? How did it hunt? How did it survive in oceans that were both similar to and vastly different from our own? And perhaps most intriguingly, why did it disappear? Because extinction, especially for a creature so dominant, is rarely simple. It is a story of changing climates, shifting prey populations, evolutionary pressures, and sometimes competition with emerging species that rewrite the rules of survival. And here, the mystery deepens. Because during the time Megalodon ruled the seas, the oceans were undergoing dramatic transformations, tectonic shifts altering currents, global temperatures fluctuating, and marine ecosystems evolving in ways that would eventually favor smaller, more agile predators, including early ancestors of modern sharks and marine mammals, and yet for millions of years, Megalodon thrived, suggesting it was not just powerful, but highly adapted, possibly more specialized than we ever imagined, and this is where the new perspective becomes both fascinating and unsettling, because recent biomechanical modeling, using advanced simulations based on fossil evidence, suggests that Megalodon's body proportions may have been drastically different from the sleek, torpedo-like form we associate with great whites, instead indicating a bulkier, more robust body, potentially closer in shape to a modern whale shark or basking shark, but with a predatory twist, a creature built not just for speed, but for immense power and energy efficiency, capable of long-distance cruising combined with devastating bursts of force. And if this is true, then the image of Megalodon changes dramatically, from a fast, agile hunter to something more imposing, more calculated, a presence that didn't need to chase relentlessly because it could outlast, outpower, and outmaneuver its prey in ways we are only beginning to comprehend. And this shift in understanding forces us to reconsider everything, from its feeding strategies to its role in ancient ecosystems, because a predator of that scale doesn't just exist within an environment, it defines it, shaping the behavior, evolution, and even the distribution of other species. And perhaps the most chilling implication of all is this, that for decades, we have been visualizing the wrong monster, telling ourselves a story that fit neatly within our understanding of modern sharks, when in reality, Megalodon may have been something far more complex, a creature that doesn't fit into the categories we've created, a reminder that the past is not simply a larger version of the present, but a fundamentally different world, governed by rules we are still struggling to uncover. And as we begin to peel back the layers of this ancient giant, the question is no longer just how big it was, but what it truly was, and whether our misconceptions have blinded us to a deeper, more unsettling truth about the nature of evolution itself. And once that illusion begins to collapse, once we accept that Megalodon was not simply a scaled-up version of a modern predator, the entire framework of how it lived, moved, and hunted must be rebuilt from the ground up, because biology does not allow for simple exaggerations of size without consequences. Every increase in mass demands changes in structure, metabolism, and behavior. And this is where the deeper science reveals something far more intricate than the brute force hunter we once imagined. Because when researchers began analyzing the hydrodynamics of Megalodon using computational fluid models, they discovered that a body shaped like a great white at that scale would face immense energetic inefficiencies, requiring unsustainable levels of constant motion just to maintain its metabolic needs, meaning the classic image of a hyper-aggressive, endlessly cruising giant begins to fall apart under the weight of physics itself, replaced instead by a creature that had to optimize energy expenditure with extreme precision. And this is where the comparison to modern filter-feeding giants like the whale shark becomes unexpectedly relevant, not because Megalodon was filter-feeding, it absolutely was not, but because of body design, because large marine animals tend toward bulkier, more stable forms that allow them to glide through water with minimal energy loss, suggesting that Megalodon may have been less of a high-speed pursuit predator and more of a calculated ambush specialist, capable of slow, efficient cruising, punctuated by explosive bursts of power, a strategy that aligns far more closely with the fossil evidence of bite marks found on ancient whale bones, where patterns indicate sudden, catastrophic attacks rather than prolonged chases. And these bite marks themselves tell a story that is both precise and horrifying, because the spacing, depth, and placement suggest targeting behavior, not random feeding, with many fossils showing damage concentrated around the rib cage and vital organs, implying that Megalodon may have developed highly specialized hunting techniques designed to incapacitate large prey quickly, perhaps even learning to exploit the buoyancy systems of whales by crushing lungs or severing major arteries, turning massive, powerful animals into sinking carcasses in a matter of moments. And this level of strategic predation hints at a degree of behavioral sophistication that goes beyond instinct, raising the possibility that Megalodon's success was not just a product of size, but of refined evolutionary intelligence embedded in its hunting patterns. And when we examine its teeth more closely, not just as isolated fossils but as functional tools, another layer of complexity emerges. Because their serrations are not uniform, they vary subtly in structure, optimized for slicing through different types of tissue, from blubber to bone, and microscopic where patterns indicate repeated stress consistent with biting into dense, resistant material, suggesting that Megalodon was not simply tearing flesh but actively dismantling large prey, possibly consuming entire sections of whales rather than feeding selectively, which would have required immense bite force. And indeed, biomechanical reconstructions estimate that its bite could exceed 100,000 newtons, making it one of the most powerful biting forces ever recorded in the animal kingdom, a force capable of crushing bone with ease. And yet, even this staggering power had to be balanced against metabolic constraints. Because a predator of that size could not afford to hunt inefficiently, every failed attack would represent a massive energy loss, and so its behavior likely evolved toward precision, patience, and timing, waiting for the right moment to strike rather than engaging in constant pursuit. And this leads to another critical shift in our understanding, because if Megalodon was not constantly roaming in search of prey, then its interaction with the environment becomes more complex, suggesting defined hunting territories, migration patterns, and possibly even seasonal behaviors tied to the movements of marine mammals. and isotopic analysis of fossilized teeth supports this idea, revealing variations that correspond to different water temperatures and regions, indicating that Megalodon was capable of long-distance travel across entire ocean basins, following prey routes and adapting to changing conditions. And this adaptability may have been one of its greatest strengths, allowing it to dominate for millions of years despite shifting climates and ecosystems, but it also introduces a vulnerability, because specialization, while powerful, can become a liability when environments change too rapidly, and during the late Miocene and early Pliocene epochs, the oceans began to cool, altering the distribution of warm water species that Megalodon likely depended on, while at the same time, new competitors were emerging: smaller, faster sharks and increasingly intelligent marine mammals, including early ancestors of modern orcas, creatures that hunted in coordinated groups and may have targeted similar prey, creating a competitive pressure that Megalodon had never faced before. And here, the dynamics of survival become more intricate, because it is not simply about who is bigger or stronger, but who is more adaptable, more efficient, more capable of responding to rapid environmental change. And if Megalodon's physiology was indeed optimized for a specific ecological niche, then even slight disruptions could have cascading effects on its ability to survive, forcing it into a narrowing set of conditions where its advantages became less effective. And perhaps most intriguingly, recent studies suggest that juvenile megalodons may have occupied entirely different habitats than adults, possibly using shallow coastal nurseries to grow before venturing into open oceans. A strategy seen in many modern shark species, but on a scale that implies entire regions of ancient coastlines were once dominated by these young predators, creating a layered ecosystem where different life stages played distinct roles. And this complexity paints a picture of Megalodon not as a singular, simplistic monster, but as a dynamic, evolving species deeply integrated into its environment, its life cycle intertwined with the rhythms of the ancient seas. And as we reconstruct this more accurate image, one thing becomes increasingly clear: that the real Megalodon was not just bigger than we imagined, but fundamentally different, a creature shaped by constraints and opportunities that do not exist in the same way today. And understanding it requires us to move beyond familiar analogies, to accept that evolution can produce forms that defy our expectations, and that the most dangerous predators are not always the fastest or the most aggressive, but the ones that are perfectly adapted to their world, until that world begins to change. And in the end, that is where the story of Megalodon becomes less about a creature, and more about a threshold, a moment in Earth's history where even the most dominant form of life can quietly, almost imperceptibly, begin to lose its place. Because extinction is rarely a single event, it is not a dramatic collapse or a sudden disappearance into darkness, but a slow unraveling, a series of pressures that, over thousands and then millions of years, tighten around a species until survival becomes mathematically impossible. And for Megalodon, that unraveling appears to have been driven not by one catastrophic force, but by a convergence of changes that reshaped the oceans it once ruled. Because as global temperatures declined during the Pliocene, the warm, nutrient-rich waters that supported vast populations of large marine mammals began to shift toward the equator, compressing ecosystems into narrower bands. And for a predator as large and energy-dependent as Megalodon, this meant a reduction in accessible prey across its range, forcing it to travel farther, expend more energy, and compete more intensely for diminishing resources. And at the same time, the very structure of marine food webs was evolving, because smaller, faster whales were emerging, species that relied less on sheer size and more on agility and social behavior, making them harder targets for a predator built for overwhelming force rather than prolonged pursuit. And this subtle shift in prey dynamics may have been one of the most critical turning points. Because evolution does not need to defeat a predator directly. It only needs to make survival slightly less efficient, slightly less reliable, generation after generation, until the balance tips. And alongside these changes came the rise of a new kind of competitor, one that did not rely on size at all, but on coordination, intelligence, and adaptability, the early ancestors of modern killer whales, apex predators that hunted in groups, communicated, strategized, and could exploit weaknesses in ways that a solitary hunter, no matter how powerful, could not easily counter. And while it is unlikely that these early orcas directly hunted adult megalodons, The overlap in prey and territory would have created a competitive landscape unlike anything Megalodon had faced before, where efficiency and flexibility began to outweigh sheer dominance, and this is where the deeper lesson of its extinction begins to emerge. Because Megalodon was not simply outmatched, it was outpaced by change itself. A creature exquisitely adapted to a world that no longer existed, and as its preferred habitats shrank and its prey became less predictable, its life cycle may have been disrupted in ways we are only beginning to understand, because those coastal nursery grounds, once safe havens for juvenile megalodons, would have been among the first environments to be affected by shifting sea levels and temperatures, potentially exposing young sharks to new predators and reducing their chances of reaching adulthood. And when a species depends on such a delicate balance between growth, reproduction, and survival, even small disruptions can have exponential effects over time, gradually reducing population numbers until recovery becomes impossible. And what makes this particularly haunting is that there was no single moment when Megalodon vanished, no final battle or defining catastrophe, just a fading presence. Fewer individuals, fewer sightings in the fossil record, until eventually, the teeth, the only echoes it left behind, simply stop appearing in younger geological layers, marking the quiet end of one of the most formidable predators to ever exist. And yet even in extinction, Megalodon continues to shape our understanding of life, because its story forces us to confront a fundamental truth about evolution, that success is always temporary, that dominance is not a guarantee of permanence, and that the traits which make a species powerful in one era can become its greatest limitations in another. And perhaps this is why we were so drawn to the idea of Megalodon as a giant great white, because it allowed us to anchor the unknown to something familiar, to believe that the past was simply a more extreme version of the present, rather than something fundamentally different, something that challenges our assumptions about how life adapts, survives, and ultimately disappears. And in correcting that misunderstanding, we do more than just redraw the image of an ancient shark, we reshape our perspective on the natural world itself, because Megalodon was not a monster in the way we imagined, not a mindless engine of destruction, but a highly specialized organism, finely tuned to its environment, operating within the same constraints that govern all life. And its extinction was not a failure, but an outcome, a reflection of a planet in constant motion, where climates shift, ecosystems reorganize, and even the most dominant species must eventually yield to new forms better suited to the changing world. And there is something deeply unsettling in that realization, because it means that no matter how powerful, how adaptable, or how successful a species may seem, it is always part of a larger system that it cannot control. And in that sense, Megalodon's story is not just about the past, but about the present and the future, a reminder that the forces shaping life on Earth are ongoing, that the balance we see today is temporary, and that the same processes which erased a giant from the oceans continue to operate around us now, quietly, persistently, reshaping the world in ways we may not fully understand until it is too late. And perhaps the most haunting question of all is not why Megalodon disappeared, but what it reveals about the nature of survival itself, because in the end, evolution does not reward the biggest or the strongest. It rewards the most adaptable, and when the world changes faster than adaptation can keep up, even giants vanish without a trace, leaving behind only fragments, clues, and the unsettling realization that we were never as certain as we believed.